Yes, you've read the title correctly. Today we are taking our love for arbitrage cross-chain. So pull your seat, sit down, relax, open your laptop, and code along with me. If you're new around here, my name is Abolaji, and on this channel, I don't just teach you solidity smart contract development. I teach you how to exploit the opportunities on blockchain. Basically, we are going to create smart contracts that are able to buy token on one blockchain, transfer it to another blockchain, and sell it. In the process, taking advantage of price discrepancies across these blockchains. So, these are the learning objectives we are going to be able to achieve with this course. It's going to be series of videos, and for that purpose, please like, subscribe, pin the notification button so that you get notified of my subsequent videos on this topic. So at the end of these videos, you'll be able to set up Foundry environments. You would also have been able to write smart contracts in Solidity, and with your smart contract, you would have been able to interact with contracts using ABI.encode function. That's a low level function in Solidity. You would also have been able to fork base Sepolia testnets and Arbitrum Sepolia testnets. That's where we'll be testing locally. You would also have learned how to interact with DEXs like Uniswap V3 and Aerodrome V2. Now, you would also have been able to integrate Chainlink price feed into your contracts. You'll learn how to do that as we progress in this course. Then you would also learn how to transfer tokens across Base and Arbitrum Layer 2 blockchain using across protocol. So we are going to be using across protocol, across bridge for this purpose. And no, this video is not sponsored. If you know across, the guys in across, tell them to come and sponsor this video. I'm just using across protocol because it's about the fastest bridge out there. They are able to fill your request in less than 3 seconds. So it's quite good for this purpose. Send also, you would also be able to send cross-chain message using across. Then at the end, you would also learn how to deploy your smart contracts to Base and Arbitrum testnets. We are not going to deploy to a mainnet. We are not going to play with real fund. This is for educational purpose. Then we would also make API calls to across protocol. By the way, if you want to integrate blockchain solutions into your business, or you have an idea of a blockchain application and you want me to write that for you, or you just want me to audit your code and take a look at your code base for you, please check the description to this video, book a call directly with me, and I'll take it from there. If you're a parent, you need to check out seekerquest.com. Seekerquest allows you to generate fun offline activities for your kids. The activities here are quite amazing. So you just select the age group, whether you want to do math activity, game, or riddles, and select the appropriate difficulty level, and you generate. It's as simple as that. You can share your thoughts and you get response from AI about the child's response. So please check this out. Check the description to this video and you see the link to. Let me show you the overview of what we are building today. I'm going to zoom in so that you can see. Let me just move myself out of the way. All right. So we have the base blockchain side of things. You can see the smart contracts there, the cross-chain collar contracts, the across protocol side of things. We have the bridge, and we have the Arbitrum blockchain side of things. We have the across protocol side contracts, and we have the cross-chain collar contract. Now, the cross-chain collar contracts are what we are going to write. Across protocol have these contracts already existing, deployed, living on base blockchain, and they have the equivalents on the other side of things, on the Arbitrum side of things. All right. So what we are going to do, we as user, we are going to deposit into the cross-chain collar contracts. We are going to make maybe the token we want to transfer, so wrap Ethereum or USDC. So, and if we need to also swap before that, we can call this swap on USDC on Uniswap V3 or swap on Aerodrome V2 to get the right token here. Now, then we'll call this function called bridge token to other chain with message. All right. So when we call this function is going to transfer our wrapped Ethereum to the across protocol or whichever token we specify. Now, it's not just going to transfer the token, it will transfer it with a message we are going to encode. Now, this message can be anything. So think of it as you sending money from the UK to Nigeria now and giving instruction to the receiving bank in Nigeria that, oh, I'm sending this money for my friend to my friend. When he gets this money, when he comes to cash it out, tell him to buy food for my grandparents in Nigeria. So that's a good example I could give. So in this case, the message we are going to be sending along with our token is that when our token gets to Arbitrum side of things, it should be swapped to to USDC, swap from WET to USDC. All right. So back over here, wrap the Ethereum in the across protocol. The across protocol will now transfer our token to Arbitrum side of the blockchain. Now, it does not in reality, in theory, that's what happens, but in reality, it doesn't actually transfer it. What it does is it locks up our wrapped Ethereum here, send a message to this across spoke on the Arbitrum side to release the equivalent of our wrapped token here for us. So it's going to release wrapped Ethereum for us. Now, because we have encoded message to with our token, so it's going to now transfer our token to multi-core handler contract. This multi-core handler contract would be the one to transfer our token to the destination side of things. On this side now, as the token arrives here, the multi-core handler immediately call this function swap on Uniswap V3 on our contract, and our contract sends the wrapped Ethereum to Uniswap V3, swap it to USDC, and swap it and keep the USDC on the contracts for us to withdraw. So that's the overview of what we are going to be coding today. So let's jump into our IDE and get started. Before we get started, I'm currently creating a 12 to 24 weeks training course on smart contract development, auditing, and blockchain decentralized application automation. It's going to be a comprehensive training course, and mainly it will be a one-on-one section. I'm not taking more than 10 students at a time, and so that I can take you from any level you are in, whether you have written code before or you've never written any code before, and make you into an expert. If you are interested in this training course, please leave your comments below, and once my waiting list page is ready, of course I'll let you guys know. Go on our IDE and get started. If you don't have an IDE, just come to Google and search for Cursor download, and it will bring up these options, and you can click the first one. My IDE is Cursor. I'm also quite used to VS Code. Whichever IDE you're comfortable with, you can use it. So you can download Cursor. So just click this first one, and it takes you to the page where you can download for Mac OS. I'm using Mac OS. If you're using HP, it will definitely give you the option for Windows. All right. So after downloading, after your installation, you would have a blank screen like this. So this is your IDE. Now you can now create a folder. After creating a folder, click File up here and click Open Folder. So you can open and we'll be working inside the folder you have created. So I created a folder and I name it cross-chain arbitrage bots. So everything we are going to create will be inside this folder. Now let's start by installing dependencies. The first dependence we need, it's the Foundry. That's the framework that allows us to write in Solidity, also interact with deployed contracts in Solidity. In yeah, um, later we'll install Node.js and also play around with TypeScript. So the first thing now, if you um, press Command J, it brings up your terminal. Command J. If I'm using Mac OS, if you're on Windows, it should be Control J. I'm not sure about that. So or you just come up here and click terminal and open new terminal. All right. So after that, the next thing is for us to install Foundry. We will have to go to the Foundry documentation. So you can come to Google and search for Forge documentation, and this first option takes you to Forge documents. That's Foundry documentation. All right. So I'm going to leave the link to this documentation in the description of this video. So just scroll to installation over here. Then this is what you're going to copy. You're going to copy this command and go to your terminal and run it on your terminal. You paste it here and you run it. I have it already installed, so I don't have to run it again. But to be sure that what you have done is correct, you should be able to run forge dash dash version afterwards, and it's going to give you the version after this. So this is what you're going to get. Then that shows that you have installed it correctly. Then the next thing is, come here. There are a few extensions that will make this easier for us. So click this icon here that looks like ties, and search for Solidity. Solidity. All right, this first one, John Blanco. Okay, so click this. You can install this. I have it already installed, just to make the visualization of our Solidity code to be okay. I think that's about what we need. All right, so we can now start coding. So let's close here, then press this file. All right, everything is okay. You can right click on the terminal and click clear. If you're using VS Code, I think Command K should clear your terminal for you. So the first thing is, in our directory, we are going to run forge init to bootstrap the project. So I'm going to run forge init. So all right, so we have everything. Yeah, this is our source folder. This is where all our contracts will be written in, or we just have a placeholder. Now if you do Command J, it's going to hide our terminal. So I just did that now. So the test folder is where our test will be in. We are not going to write unit test or integration test. We are just going to write scripts for testing. Yeah, so that's it here. So let's get started. We wouldn't need all these placeholders, so I'm going to delete them one after the other. Move to trash. Move to trash. Then I'm going to right click. I'm right clicking on each of the files and deleting them. All right, so it's blank. We can now put what we want to put there. I'm going to come to the source folder and I'm going to create a new file and name it base to other chains color. So this will be our contracts on base. Now the first thing is, when you're writing a contract in Solidity, the first thing is you have to define the license. So this is SPDX license identifier MIT, and you're going to state the Solidity version you're going to be using. In this case, we are going to be using 0.8.24. All right. So then the next thing is, we need to now define the contract itself. So to create a contract, you start with the contract keyword, the name of the file, exactly the name of the file, and you end it with the curly bracket. So every code you are going to be writing will be inside here now. So, must have a constructor. So constructor, yeah, okay. It's just going to be a blank constructor. I don't mind these autocomplete. All right. So we have a blank constructor. Think of a constructor as a function in the smart contract that runs once, and it's only at the time of deployment of the contract. So let's say we are deploying it to the blockchain now. This constructor runs automatically, and all the code we put there runs once. You can't call it afterwards, it just runs. So yeah, you would see how we make use of that. Now, the first thing we are going to do is to list out the things we are going to implement. So the first thing is, number one is we need some kind of function that we can call, and it will bridge our token. It will start the bridging of the tokens. So we have a function to initiate bridging of tokens to other chains. All right, let me spell this correctly. All right. So the second thing we'll need is we need a function to swap tokens on Uniswap v3. Then we also need a function to swap on aerodrome v2. Aerodrome v2 is not available on Arbitrum, so this we may not need it when we are writing the contract for Arbitrum and other chains. So the fourth thing is a function to withdraw tokens, to withdraw tokens from the contract. Tokens from the contract. So if we have funds on the contract, we can withdraw it after our swap. And the next thing is a function to also withdraw ETH. If someone send Ether to us, so we don't want funds to be stuck on the contract, a function to withdraw Ether. So these are the things we are going to implement. Just 5 functionalities, but there are many other helper functionalities that we'll need to also implement as we go along. Come back here. Now, the first thing is we want to initiate a function. We want to write a function to initiate the bridging of tokens. We said we are going to be using a cross protocol. That means that we have to be interacting with a cross protocol. Now, I told you earlier that across has deployed contracts. Now, for us to interact with deployed contracts, we need to interact with deployed contracts. We need two things. The first thing is we need the ABI or the interface of the contract. And the second thing is the address, the contract address of the contract Now let me break that down. What that means is this ABI or interface. ABI stands for application binary interface. Sorry about what this thing is doing. So ABI stands for application binary interface. Sorry, the autocomplete on cursor is just driving me crazy. So I need to quickly turn it off. So I'm going to come to cursor tab here, just over on it, then disable here. Yeah, that should be okay. So address and ABI. Address, the contract address defines where a contract is living on the blockchain. So we need that address. ABI and interface. So let's think of a contract living on the blockchain as a company. All right. So address is the address of the company. Now you want to talk to the company. ABI or the interface defines which position you can talk to in the company to get the information you need. So it tells you can talk to the manager, you can talk to the HR manager or the CEO. These are the people you can talk to in the company, in the interface. So ABI stands for application binary interface. Now this is low level. So what we are going to be working with is interface. The interface of the contract, when the compiler works on it, it compiles it down to the ABI, to the application binary interface. So all we just need to get is the interface. So we need to now get these two things, the interface and the contract address for across protocol. Now to get the ABI and contract address, we are going to come to across documentation. I'm going to leave the link to this documentation in the description of this video. Now, you're going to navigate to selected contract functions here in the navigation bar. So this is what we are interested in, the deposit v3 function. That's what we are going to be calling. So we are going to click this and it's going to take us to GitHub for the across protocol. So this GitHub page contains the interface for the contract v3 spoke pool that we want to interact with. Of course, we are going to copy this, and that's the interface. Now the next thing, we'll come back here, we need the contract address. So if we scroll down here, we'll see here contracts, where contracts are written. When you click here, we are interested in base blockchain. So base blockchain contains the contract address of the across contract on base blockchain. So we need base spoke pool and multi-handler. We'll still come back to multi-core handler. So we just need to copy this address. And if you click it, it's going to take you to the base scan, the explorer. And this is the contract itself. All right, so we have both, and let's get back to the IDE. Here, I'm going to come here and create a folder, and I'm going to name it interfaces because we have many contract interfaces we are going to be importing. So here, I'm going to create a file, and I'm going to call it hi across spoke pool dot so. It has to end with dot so. That's how you define contract in Solidity. So here inside this file, I'm going to paste the contract interface we copied from the GitHub. You can see it. So we now have the contract interface. The next thing is to come here and import this contract interface. So this is the contract interface. copy the name, come over here and write import. This is how you import. Import this from, then you have quotes. Then we are going to put the directory of this, of the interfaces. So the first thing is this current directory slash interfaces slash let me just copy this name so that I don't make a mistake. Here dot so, then you end with semicolon. Alright, now we have the interface here. Now we're going to declare our first state variable, but actually it's going to be state constant. Now this is immutable. With this immutable keyword, you're stating that across spoke pool address, that's the address, this variable will hold the address of the across spoke pool contract. So we are saying that we are going to initialize its value during deployment inside this constructor. And once we do that, we would not be able to change the value of this variable anymore. That's why it's called immutable, and it's a way to also optimize gas in solidity. Once solidity see this immutable keyword, it will not create a storage slot for it, for this variable. As we progress, I will explain that even more. All right, so over here in the constructor, that's where we are going to pass the address of the across spoke pool contract. Once we pass it into the constructor, and you'll see our deploy script later, we are going to set this to this value that we just passed in. Let's create an instance of the contract itself. So I'm going to come down here and I'm going to create an instance of this, of the V3 spoke pool interface. So what that will allow us to do is to wrap inside this constructor. We are going to get the instance of the contract by wrapping the interface around the contract address. So we now have the full contract here that we can interact with. Quick one. In my previous video, I've seen comments of people talking about me sharing the code for the contract itself. My reason for not sharing the code is that I've seen many scammers sharing their code base just for people to download the wrong thing, and they steal people's fund. So what I'm going to do is that I have these contracts that I deployed on the testnet. So I'm going to share this link. I'm going to leave this in the description of the video. So the contract is verified. When you come to this page, just click contract, click code, then you'll see what we are coding. This, although it's not going to be exactly what we are going to code, I've made some modification because this was when I was preparing for the video. So I'm going to, but here you can get the gist and follow along. I'm going to leave the link to this in the description of this video. Back to the hide.